Hello and welcome to another episode of Tutorial Thursdays. After the last video where we analyzed the redundant sensor problem, one of our customers reached out and actually introduced into yet another way to solve the same problem. So that's what we're going to look at today. I'm going to follow the same steps that he followed to come hopefully to the same end result. So that being said, let's dive in. So just like in the last Tutorial Thursday, I'm going to start from the same view with my two level sensor readings, level sensor 1 and level sensor 2. And very clever, as indicated by one of our customers, we can actually use yet another way to find whenever this correlation, and that's what we're going to use, the correlation between the two signals is broken. Now, of course, to use the influence factors in the right way, so influence factors looking for correlations, of course, I have to zoom in to only the period where that correlation exists so that I can properly train again the model, if you may, to do that correctly. So my tag of interest will be level sensor 2 that I'm going to ask TrendMiner to analyze and come up with a way, level sensor 1 of course is going to be the main input here, to approximate that, that trend. As you can see now, the original pink line has been approximated with the dotted line, which is using the level sensor 1 as the input. I still see a little bit of that jaggedness that we were talking about last time, so I'm going to expand my search and I can add, in this case, the level sensor 1 smoothed as a potential input. Maybe that's going to work a little bit better. And let's add level sensor 2 as well. And hit the analyze again. If I don't want to select my inputs up front, I can use a global search so that I can look through all tags in my historian. But of course, in this case, I have worked on those tags last week, so I know already that those are going to be interesting. So I'm going to leave that unticked. I'm going to manually add the inputs. Of course, the level sensor 2 smoothed is going to be very close because it has that level sensor 2 as the input. So I'm going to ignore that one. But I'm going to use the level sensor 1 smoothed. And as you can see, those signals match up very, very closely. Because I'm looking at a long period of time, I'm looking at 5 days, and the smoothing that I introduced last time is taking care of those deviations. So that looks like a perfect model to me. I'm going to save that, so I'm going to store that with a little floppy disk. And you see the linear model there has been calculated. I'm going to give this a name, level sensor 2 approximation. That's going to be my first step. So basically just creating almost a soft sensor for the second level sensor using the other level sensors as input. And as you can see, that model, there's going to be a little bit of wiggling, there's going to be a little bit of deviation, but overall it's matching very closely to what I'm looking at. And now here's the deal. This is really the clever step that this customer came up with. Once I have this approximation, what I can do is switch this to stacked or to a scatter mode, and look at that perfect correlation here. And that's what I'm going to use to detect whenever I'm going off of the normal behavior. So I'm going to change the scales here a little bit to zoom in a little bit better. Let me actually go back into the trend mode. And in this case, of course, I have to select the tag that I'm using. I'm going to go here from about 40 to about 50, well, I guess 55 would be okay. So I have a very good view on that tag. And if I now go back to the scatter mode, you see that's almost a perfect line, right? That's the correlation analysis I did. Now the next step, and this is really clever, I can use the area search now to detect whenever I'm going outside of these of that perfect line. So I'm going to add an operating area search. I'm going to draw a nice line, a nice polynomial or a polygon, sorry, around this area, and hit save on that. So that looks like a very neat correlation. I'm going to ask TrendMiner, when am I outside of that area for example, at least 2 hours or 2 minutes. And what you see is that, well, I find one deviation in the beginning, and then I find very clear deviation happening at the end. So again, that's something I can fine tune. For example, I can go back and I can add maybe 2 hours. Let's see, and there you go. I only find the period of the upset, again starting around 8th of October, very similar to the results that we had last time. But I thought it was very cool and worth it to share with you guys. Multiple concepts to look at the same problem, but that's the beauty of self-service analytics. Multiple ways lead to Rome, as we say. So in this case, multiple ways to detect or early detect the problem that's happening. Because again, in hindsight, it's very easy to spot once you have all the information, but as it is happening in real time, it's rather hard to see. All right, there we have it. Pretty cool way. Another way to find the same solution or the same detection of the event, the drift of the two sensors happening. Now, in my example, of course, I took a couple shortcuts. So I didn't, for example, look at the whole spread from 0 to 100 for the level. So I just used a little bit of the data I had available. In real life, you probably want to extend that window, so that polygon that I was drawing, to capture the full range. But the concept is going to be the same. So thanks to our customer for mailing that in, and hope you enjoyed it as well. See you next time.